In teaching calculus, there's something that I always like to say. Derivatives are easy and integrals are hard. Derivatives are relatively easy because you have various different derivative rules like product rule, quotient rule, chain rule. They're fairly universal for most derivatives that you would have to do. Integrals, on the other hand, since they're derivatives in reverse, really require that you think through what form is it? What types of readjustments might I have to do? What substitutions might I have to do? And there's very many other methods in order to do integrals. And really, in order to do them well, it just requires a lot of time, practice, and experience, and a lot of patience before you get very good at doing integrals. So here's an example, for instance. It requires us to have a little bit of insight in terms of how to do this and recognizing the different forms. Now, unlike derivatives, we don't have a quotient rule for integrals. Rather, we have to think of what form is this. So, we have x plus 2 in the numerator and the square root of 1 minus x squared in the denominator. Something that we can do is we could go ahead and split this up into two separate integrals. X over square root of 1 minus x squared dx, and then I'll just say plus, and I'll split it up into the second integral over here on the right. All right, for the first integral, we want to think through what form is this? Well, if we consider the square root of 1 minus x squared in the denominator, we can think of u as being just the 1 minus x squared. And if that were the case, if we think of u being equal to 1 minus x squared, and the derivative of that being negative 2x dx, well, it looks like we can rewrite this by making an adjustment with just the negative 2. So what I'm going to do is go ahead and rewrite this as, I'll write this as 1 minus x squared. It's to the negative 1/2 power, and then I have the x and the dx still there. And since we need to have a negative 2x, the proper derivative of the 1 minus x squared, I'll put negative 2 there, and then compensate with a negative 1/2 in the front of the integral. Again, remembering you could always adjust by simply a constant. And then what happens here is we have the integral of 1 minus x squared to the negative 1/2 with the proper du, negative 2x dx. This ends up being negative 1/2, and then we have 1 minus x squared. Then the power goes up by 1 to positive 1/2. Remember, we divide by that new power, and we end up with simply negative 1 minus x squared to the 1/2, which would be square root 1 minus x squared. And of course we would have a plus c, but we're going to wait until we're done with the whole problem to insert the plus c. So that would be the integral of just the first half, having split it up into two separate integrals. Now the second one, we can simply look at that as, well, factor the 2, and we have 1 over square root of 1 minus x squared dx. And that simply is the derivative of arc sine. So this is directly plus 2 arc sine of x. And then to complete the integral, of course, a plus c. So your final answer ends up being the sum of these two integrals added together. Negative square root of 1 minus x squared plus 2 arcsine of x plus c.